All right. Okay. So we're going to learn about learning more about the possibility of life on Mars in Death Valley. Do people know where Death Valley is? Has anyone been to Death Valley? People saying something in the chat. Are there any people from California?
There's quite a few people that have said no. We did have a couple of people say yes, California. Okay. So we're 50-50.
Excellent. Okay. Well, for the people who don't know where Death Valley is, I'll give you an introduction to that. For people who have been, well, it'll be nostalgic for you to see some pictures. All right. So these are all the places that I work with. I work with McGill University, the Mars Science Lab team, Los Alamos National Laboratory. That is in New Mexico in United States, and astrobiology department at Open University, University of New Mexico. So thank you to all those people who helped me, and also to Let's Talk Science for letting me speak to all of you wonderful people. All right, so here's a broad introduction of what I do. So you see two pictures here. The picture over here shows a black and white image of Gale Crater on Mars. So Gale Crater is a crater, as the name suggests, on the surface of Mars. So basically there was an impact by a meteorite, and it formed a crater on surface of Mars. And this is where the Curiosity rover landed. If you look at the star, this is the position where the rover landed, and this red line that you see, red line that you see over here is the rover path so far. So this is how much it has traveled, and it's around 21 kilometers in the past 12 years, I want to say. 2008. Yeah. Yeah. So and if you look at the right side, you'll see these squiggly white lines. So these are basically what we call evaporites. So evaporites are minerals that form when water evaporates. Basically, if you've done the experiment of like mixing salt in your water and then leaving it out, it crystallizes as salts, right? So salt is an evaporite. So if the water has stuff mixed inside it, and the water dries off, what the water leaves behind are evaporites. So evaporites on Earth, I mean, they're very important. They're very great to study, because even if the water is gone, it kind of gives us the idea of what the water was like, based on the chemistry of these evaporites. It tells us what could have been the temperature, what could have been the pH. So pH is basically a measure of acidity or alkalinity. Like lemon is acidic, and soda water is alkaline. So if you guys haven't studied pH yet, that's okay. It's basically the chemical condition of the water. And this is really important on Mars, because today, on today, in today's terms, Mars's atmosphere is not dense enough to support liquid water. And we're constantly trying to understand if Mars had liquid water, because on Earth, water is highly associated with life activity. Whenever you see a water body, there's always algae, there's always other animals that are coming to the water. So if we're looking for life on Mars, it's important to understand if there was water on Mars. And especially because these evaporites that you see right here are actually underground. These have sort of pressed into the rocks, and they've kind of like, taken the space between the rocks. So they're also protected from harmful radiations on the surface of Mars, and they might actually have the right ingredients to preserve life. So why did I choose the element boron? Someone raised an excellent question. What is boron? It is the fifth element on the periodic table. It's quite light, and very water soluble. So basically it goes where the water goes. If you've noticed salt, which is sodium chloride, it mixes very well in water. So sodium chloride is very water soluble, but that's a molecule. Boron is an element, it's just boron. But boron also forms borates. It can be sodium borate, it can be calcium borate, and all of these are also very water soluble. That means it's like sugar. You know, when you put sugar in water, it dissolves, right? So this dissolves in water, and this water can travel anywhere. So it takes, so imagine if you have sugar water and you pour it over, you know, a table. I mean, don't do that. But the sugar will travel with the water on the table. So that's what boron and borates do too. It kind of goes with the water. So it gives us a really good idea of where water could have been. It's like, you know, detective work. We want to know where the water went, but there's no water. So we look at the things that traveled with the water. And boron was, why am I studying boron? Is because we found quite a lot of it in Mars for the first time in 2016. So Dr. Patrick Gazda, who you saw on previous picture, was the first person who discovered boron in situ, as in by the Curiosity rover on Mars for the first time. So it's a new thing and it's really exciting. On Earth, boron is also known to support prebiotic elements. So what do I mean by prebiotic elements? So you guys have probably heard about DNA. You know, it's basically the building blocks of life. So boron is known to support the structure of RNA. So RNA is like DNA, but it's a single helix. DNA is a double helix. So if you look at this image over here, this is a single helix. When you think of DNA, you know, if you look at the DNA emoji on your chats or whatever, it's usually a double helix. So this whole structure is made of these like little molecules. These are called a ribose sugar. These are all words, you don't have to worry about it too much. Basically, our genetic coding is stored in structures like these. Ours is a double helix because we're more complex creatures, but simpler creatures like algae and, you know, like single-celled organisms often have RNA. So boron is known to prolong their life. So boron can almost be like a multivitamin for, you know, early life. And boron is also found between these rocks where harmful UV radiations can get to. So it's a really good spot to kind of, you know, foster life. So yeah, that's why I started working on boron. But how do I measure boron on Mars? With lasers. So this is the Curiosity rover, and this is the head of the Curiosity rover, which is called the ChemCam unit. And the ChemCam unit, if we zoom in a little bit, has this. And if you look at this little eye, it's like a cyclops. It has this little area which is called LIBS, which stands for Laser Induced Breakdown Spectroscopy. And with this, we kind of shoot holes on Mars rocks or Mars soil. So here's a little laser, and it shoots this spot. It's a very small spot. I think the thickness is about, you know, if you put like four strands of your hair together, that's how thick the hole will be. And if you look at this is actually an image from Mars. It's like, you know, a couple of images put together. It's making this hole in Martian soil, and it turns it into plasma. So plasma is the fourth state of matter. It's very hot. It's basically like a fireball. So it, you know, raises the energy levels of this material and gives us a chemical signature of what this rock is. So basically, here's the laser. It shoots a very high-powered laser onto the rock, and it forms this glowing plasma ball which contains all the information. And there's a camera, or a spectrograph, it's a fancy name for a camera, that actually captures the image of this plasma. So the plasma just contains all the chemical information, and that looks like this. If you look at the squiggly line, it tells us what wavelength, what is the chemical fingerprint of this rock, and how much of there is is in the rock. So that's what it looks like from my side. But what is the boron story? What do we actually come to know from it? So here's I've kind of summarized this in a bunch of pictures. So oops, yeah, okay. So this is Gale crater. Um, if you remember the image from the black and white image from the first slide, Gale crater is basically like, like a little, not a little, it's 5 kilometers. It's a depression on the surface of Mars. And when it was a wetter, warmer period, we think there was a lot of water that, rained on the surface of Mars, and like the water kind of wore down the rocks and then formed soil with it that just got dumped into this crater, and it formed a lake. And there are also these cracks because the surface of Mars was impacted by a crater. The base of the crater had lots of cracks in it. When you smash something glass, there's a lot of cracks in it. So those cracks in a wetter, warmer period on Mars got filled with all the water that was, that rained on Mars, and if there was long-standing lake that just kind of seeped in. But eventually, for some reason, the wet, warm period ceased to exist on Mars, and it started becoming drier. So there wasn't any more rain. Whatever water was on surface started to dry out, and as the water kept drying out, the water became more briny. You know, when you have a salt mixture, if you leave it out in the sun, when the water goes away, the remaining water will become more and more salty because it's no longer diluted. The ratio of salt to water is quite high. So that's what probably happened on Mars, and that probably reflected in the these crack, the water that went down into the crack too. Eventually, even this surface water went away, and the protective covering on these sediments that were deposited in the crater, uh, they were exposed. So wind came in and kind of like gouged through it. They just eroded it away. So this overlying pressure was gone. So what happened was that this water underground started pushing into the rock that was remaining here, that formed these cracks and seeped into the fractures of this rock. Eventually, this water also evaporated and left behind the little squiggly lines that we see today, which is incredibly valuable because it basically captures the entire story of what could have happened on Mars. So, the rover is around here somewhere measuring these little veins, thinking about the whole process of water that could have been present on Mars. Um, so yeah, if you look at the image on top here, you see these veins on Mars. But when you look at the image below here, they're quite similar. Even though Mars and Earth are two different planets, um, the physical and chemical processes, the elements themselves are going to remain same, even though the parameters are a little bit different. So we don't have a geologist on Mars yet. One day that'll be possible, maybe. But if we want to learn more about these things, a great way to go about this is look at similar features on Earth, and that's another part of my research. So what I did was try to look at these, like try to find these veins on Earth, and I did a bunch of research to kind of understand what is an environment similar to Mars, and how can I get to know more, because the Curiosity rover only has limited number of instruments. You can only do limited amount of research on the rocks there. So to learn more about that, I want to have these samples in my hands. So Earth is the next best example, so that's what I did. And I chose Death Valley in California. It's Southern California. Why did I choose Death Valley? Because I did a bunch of research and tried to look at, evaporites, and found out that, yeah, there could be borates and sulfates, the evaporites that I'm interested in Death Valley. And Death Valley is just a really cool place to be, right next. a little south of Death Valley, there's also this borax mine. So borax is a type of borate, the salt that I'm really interested in. Here's the mine, and it's in the city of Boron. And I really wanted to go to Boron. My research topic is Boron on Mars, and I definitely wanted to go to a town named Boron on Earth. So yeah, I planned my field trip around it. And if you look at these images over this image is so similar to what we are seeing here. This is an image that I took in field. Of course, I didn't know that before I planned my field trip, but yeah. So I am basically I work in the lab. So this was my first self-planned field trip. So I had to do a lot of work, a lot of planning, had these maps laid out, had this little calendar, and Death Valley maps, and did a lot of planning. And I had applied for field permits and also the money to go to the field. I wrote to National Geographic for that, and they agreed to give me the money for that. And with that money, I bought camping gear. I didn't have any camping gear. I bought tent, sleeping bag, first aid kit, and that cat's mine, self-financed. Nat Geo did not pay for that one. And I went to my department to get hammers and GPSs, so this would help for my field trip. Then we planned a route. This is a map, a Google Earth map of where we landed. This is Las Vegas. Oops. Las Vegas right here. We landed there, and this is our whole path. We went to this area and took all the way over here, and I'll show you pictures from there. Our first day we spent at Furnace Creek Campground. It was beautiful, and I thought that I'll be camping under the stars. It'll be beautiful. It'll be amazing. It'll be a great start to the day. But it was a little more complicated than that. I woke up, I think the first night I was there, the whole night there was a dust storm, and I woke up to go brush my teeth, and I came back to my tent to see my tent like this, entirely covered with a very generous layer of dust. That felt not very great, but I guess it was an immersive experience, because on your right side you can see these things going through in Mars. They're called dust devils, and quite similar to dust storms. So anyway, it was worth it, because that day I got to collect really good samples, and there wasn't any rain or any dust storms. We got lots of samples that look like what we'd see on Mars, and that was very exciting. And eventually the sky cleared up and the stars looked really beautiful, and I bugged my field assistant to go take me to this nearby area called, it was an old abandoned mine. I was like, we have to go and take some pictures, and it was really nice. But there were already photographers there that were also enthusiastic to go and take pictures of the night sky. But yeah, I think you can see this thin line over here. Could be a satellite, could be a shooting star, I don't know. Yeah, it was really nice to take those pictures. And eventually we also got to see these really beautiful salt flats. When you're standing over here and looking at this whole beautiful scenery, you start wondering, is this the primordial soup? Is this where life started? So much water evaporated from here. So think of how concentrated that water would have been, and all kinds of gunk that could have started life. Eventually we moved on to Boron, the town that has the borax mine. So this was our mine day. I contacted the mine people to give me a permit to collect some samples. This was the first time I was going into a mine, so I was very excited. It's amazing. It's you don't see these structures in person and from the inside on a day-to-day basis. So it was really exciting to collect samples from here. So these are all the wonderful samples that I collected. This is Dr. Patrick Asta, who was also part of that expedition that day. We brought back all these samples home, and there were a fantastic range of borate minerals. They're not very commonly found on everyday life because they're so water soluble. But we're trying to train our instrument to identify these minerals, so they become great standards. We call them standards. We haven't seen any borates on Mars yet, but that could be because the instrument on Mars doesn't actually know how to recognize them. So it acts as a really good like learn how to identify a borate. um yeah, I also got to stay in Boron Motel and got to eat in the 20 Mule Team Cafe. 20 Mule Team was the team that basically did all the mining in boron, and they said do not forget to visit the boron museum, which I did. It was like a super weird museum in a ghost town, and there was this big binder full of like pictures of Miss Boron, some pageant or whatever, from like the 1960s. And I saw that sash and I said to myself, that's a title I'm willing to fight for different reasons, of course, because I just love studying boron. Yeah, and that day, that mine day, we also visited the Antelope Valley, California poppy reserve. It was I think Southern California is known for desert super blooms. I think this was one of the times when we did see a super bloom, and the whole area was covered in this beautiful California poppies, and it was so surprising because of an Earth analog, something that is similar to Earth, something that's similar to Mars, that we think is dead and devoid of life, is actually so full of life. So maybe that just kind of made me think, like, maybe when there was water on Mars, there could have been life. We don't know yet, but an Earth analog, which is similar to Mars, has so much life. They have weird, these all sorts of lizards, chakwalas, and desert side blotch lizards. These are all things I saw and I took pictures of. And in spring, there's this tiny stream of river that forms, like I think for 3 months, and it's full of little pupfish. Um, and then in 3 months, the water just dries off, and the pupfish lay eggs underground, and then they just die. So it's amazing that there's a whole life cycle and ecosystem associated with a very harsh desert conditions. They're like caterpillars and desert bird flies. It's amazing. There are also like a myriad of wildflowers in Death Valley that is just amazing to see all the colors. It was so beautiful that I found myself like buying this pamphlet of wildflowers and identifying each one of them. And I just had to like include these pictures because they're just so beautiful, every color of the rainbow, and just so many types of flowers, blooming cacti. Look at this little bug all covered in pollen. Yeah, these are all the flowers that I saw there, and I just had to take a picture. But yeah, anyway, on the last ish day of our field trip, we went to Shoshone. The drive there was very precarious looking. It looked like the walls would basically fall on us, but it also made me feel like, is this what the rover feels like? Trying to get up all the mountains. But it was worth it because we found some amazing vein formations and got to collect some really nice samples. And it was our last day, so we found ourselves, like, after a long time of camping in the desert, we found a cafe, and I got myself a big old cup of hot chocolate with like tons of whipped cream on top, and we wrote some postcards back home. And there was one post office in the town of Shoshone, and when I went in, there wasn't anyone except a dog, uh Toby, short for October, and he greeted me, and I was like, hello, do you have an owner? Found myself talking to dog, but there was definitely a postal person there, thankfully, who helped me send my postcards to my friends. And yeah, I brought back all the samples, and ever since my fieldwork, I've been working on these samples. I've been crushing them at McGill University, forming these little pellets, and using all kinds of instruments to do similar analysis that we do on Mars, but have been doing them on Earth here at McGill University. If you look at this little box over here, here's the laser instrument that I use to analyze my samples. And looking forward, I will be comparing Mars observations and Earth observations, and I'm also going to do some theoretical modeling, which doesn't look very interesting. It just basically looks like a black box. And hopefully, with that, we'll get to understand what exactly is the history of water on Mars. And I do a lot of fieldwork progress updates, and it's on the National Geographic Explorer field note blog. It's called Finding Mars in Death Valley. I have posted the link down here if anyone wants to go and have a look. There are videos and all the updates from fieldwork and analysis, and if people, how I got to do this and how I got the funding, if you want to know more about that. And with that, I will stop my presentation. Thank you for your patience, and I'll take any and all questions.